Alright, so this is our third video. The first video we talked about evaluating piecewise functions. The second video we talked about graphing piecewise functions. And in this third video, I'm going to provide the graph for you, and I'm going to ask you to write the equation of the graph. Alright, so in this first example, I have two pieces of the graph. I have a line, which is depicted by the red line on the left. And then I have a U. Sorry, that should be closed. Then I have a U, or a quadratic, because I know that U shape we call a parabola. And that lets me know that this function is a quadratic equation. The piecewise, I have to write one section at a time. So for the first part, I have a line, and since the line is red, I'll write in red. So to write the equation of a line, I need to know two things. I need to know the slope of the line, and I need to know the y-intercept. So if I look at this red line here, I start at this, and I go, my pen's not working. I go up 1. I go up 1 and over 2. Up 1 over 2. Up 1 over 2. So since I go up 1 over 2, I know my slope is 1/2. And then my y-intercept, is right here at 2. So to write the equation of a line, I need to know the slope and the y-intercept. The slope is 1/2, and the y-intercept is 2, so my equation is 1/2 x plus 2. Now remember, in piecewise, next to the function, we have to write its domain. So this red line starts at an x value of -4, and it stops at an x value of 1. Open dots mean we are not equal to the point, so we will not put a line underneath my inequality. Closed dots mean we are equal to that point, so we will put a line underneath the inequality. At the x value of -4, it is an open dot, so I will not put a line under the inequality. On the x value of 1, it is a closed dot, so I will put a line underneath my inequality. Now we'll write the quadratic equation, and since it's blue, I will write in blue. So quadratic, if we remember, our formula is x minus h squared plus k. And to write this quadratic, h and k stands for the vertex. So the only thing I have to determine is where's the vertex. We can make this more complicated with a vertical stretch or compressed value, but since there's already so much on this test, we're not going to worry about that for now. So all I need to know is the vertex. So if I look at my quadratic, my vertex is at 4, -3. So when I fill in my equation, h is 4 and k is 3. So the equation of the quadratic is just x minus 4 squared minus 3. It opens up because it looks like a U, so I know there's not a negative out front. Next, we need to write our domain of the quadratic. So the quadratic starts at 2 and stops at 6. At the x value of 2, I have a closed dot, so I'll put a line. At the x value of 6, I have an open dot, so I will not. So when you're writing the equation of a line, we need to know the slope and the y-intercept. Writing the equation of a quadratic, we just need to know the vertex and if it opens up or down. So since it looks like a cup, it looks like a U, I know there's no negative out front. Second example, I have something that looks similar, but I have a line and a v. The last one was a u. So since it was a u, I know that's a parabola. So I know that that's a quadratic or an x squared equation. The v, if it's a perfect v or a perfect straight line, I know that is absolute value, not a quadratic. And I just wrote the equation of absolute value up at the top. So my v is going to model that equation that I just wrote. So when we're writing our function f of x, it's going to have two parts because I have two parts to my equation. So the first part, or the left part, is my absolute value. It's my v. And my vertex here is negative 2, 1, 2, 3, negative 3. My a value, so an absolute value I need to know my a value and my vertex. My a value is the slope of the lines. So my slope of the line is just 1. So since it's just 1, I don't need to write 1 instead of a, so I'm just going to leave it off. But my vertex is negative 2, negative 3. So since my h value is negative 2, I'm going to put plus 2 inside the absolute value bars, because x minus minus 2 is just plus. And since I have a minus 3k, I'm just going to put minus 3 to the side. And then again, with piecewise functions, we need to write the domain where that part of the graph is true. So the absolute value does not apply everywhere. The absolute value p starts at negative 5, and then it stops at 1. Negative 5 is an open dot, so it will not have a line underneath our inequality. The x value of 1 is a closed dot, so it will have a line underneath the inequality. Next, we have the line, and since that's in green, I'll write it in green. So remember, to write the equation of a line, I need to know the slope, and I need to know the y-intercept. So my slope here, I go up 1 over 2, up 1 over 2. So I know that my slope is 1/2, but it's also in the negative direction. We're running downhill in the equation, so I know my slope is negative. So we just put a negative 1/2. And then it doesn't explicitly state the y-intercept. The line doesn't cross the y-axis. So we have to use a little bit of reasoning here. And know that if this line were to cross the axis, if we continued one spot further, we would cross the y-axis, at positive 3. So even though our line doesn't cross the y-axis, in order to write the equation, we need to know what that b value or what that y-intercept value is. So we have to backtrack a little. The last thing we need to do is we need to write the domain. So this line starts at an x value of 2, and it stops at an x value of 10. They are both open dots in this case, so I will not have a line underneath either inequality symbol here. So writing equations of graphs, if it's a line, we need to know its slope and y-intercept. If it's a quadratic, we only need to know the vertex. If it's an absolute value, we need to know the vertex and the slope of the lines. We did our parent function chart the first day of the unit. That's going to be very important to our success because we need to know these transformation form or what information I need you to know in order to write these equations of the graph.